Assalamualaikum warahmatullahi wabarakatuh. Good morning, good afternoon, and good evening. Depends on what time you watch this video, doctor. We are from our group. Gonna present the slide about the complex that we have chosen. This slide is prepared by Noriqwana binti Mohd Noor, Nurul Farahanim binti Nazri, Zulhilmi bin Zailani, Amin Haziq bin Kaharuddin, and me, Abrar Suryadi Putra. The table of contents of our slide is first introduction, second characterization, and third translation, and fourth balance bond theory. Introduction. We choose the complex, namely base for amino, 5 pyridyl, 4H, 1, 2, 4, 3 azole, 3 thiol, cadmium. So the structure of this compound is like this. You can see in this slide actually, and the ligand of this compound is 4 amino, 5 pyridyl, 4H, 1, 2, 4, 3 azole, 3 thiol ion. The bonding type of this compound is bidentate. The coordination number of CD is 4. It connects to 2 CD bond ligand and 2 NS bond ligand. The stability of this compound obey EAN rule. 54 electron equal to xenon, so it's a stable compound. The oxidation number of CD is +2, and the geometry of this compound is tetrahedral. That's all for me. Thank you.
Thank you, Abrar. Now I will explain about the synthesis of ligand and the synthesis of the ligands complex. First is synthesis of ligand. The first step is isonicotinic acid with 1 gram and 0.0072 mole, and 0.44 gram with 0.008 mole from potassium hydroxide was dissolved in 10 milliliter of ethanol. Next, the 2 milliliter and 0.014 mole from carbon disulfide was added slowly and stirred for 10 hours. Then dry ether with 10 milliliter was added, and the yellow precipitate was filtered, washed with ether, and then dried. Then the potassium salt was added to an excess of hydrazine hydride in 20 milliliter and was refluxed with stirring until the evaluation of hydrogen sulfide. It was cased by lead acetate paper. The last step is, after cooling, the reaction mixture was filtered and then was acidified by hydrochloric acid to yield the white precipitate. The yield is 62%. Next is a synthesis of ligands complex. The first step is ethanolic solution of the cadmium 2 acetate was added to an ethanolic solution of 4 amino 5 pyridyl 4H 1 to 4 triazole 3 thiol in ratio 1:2, which is metal legend molar ratio, and reflux for 2 hours. Crystalline color precipitate was formed at room temperature. The last step is the resulting solid was washed by hot methanol and left to dry and vigorously crystallize from the ethanol. Thank you.
Now I will explain about characterization and UV spectrometer. UV spectrometer is a technique used to measure light absorbance across the UV and visible range of electromagnetic spectrum. When incident light strikes the matter, it can be either absorbed, reflected, or transmitted. The absorbance of radiation in the UV's range causes atomic excitation, which refers to the transition of electron from a low energy ground state to a higher energy level, but must absorb sufficient level of radiation. Shorter band gaps typically correlate to absorption of shorter wavelength of light. The energy required for molecule to undergo this transition therefore are electrochemically specific. Color of complexes of CST. Metal complexes have particular color caused by electronic transition induced by absorption of light. When the complex absorbs white light, the center of symmetry is disrupted. The DD electron transition are allowed in the complexes, resulting in vibranic transition. The color exhibits are caused by excitation of electron from a low energy d orbital to a higher energy d orbital, but energy must be equal to the difference in energy between the two d orbitals, which depends on the magnitude of the delta. The complex transmit the color which complementary the color that being absorbed. The complementary color can be referred to yellow of color. Complexes which have 10d electrons cannot absorb visible light because no electron can be moved from a low energy level to a higher energy level. These complexes are colorless or white. Now I will explain about our complex. Based on the table, the complex B4 amino 5-pyridyl for H124 triazole 3-thiol cadmium 2 is a white color. Based on the electronic configuration, CD2 plus ion has D10 configuration. The splitting energy diagram shows the T2J orbital are filled. To excite an electron to a higher energy level, photons of a very high energy are necessary. This energy corresponds to very short wavelength in the UV region of the spectrum. No visible light is absorbed, so the eye sees no change and the compound appears as white. That's all from me. Thank you.
Electronic transition. Like my friend mentioned before, this is our complex. Now I will explain to you about electronic transition. Interaction of molecules with UV and visible light may result in absorption of photons. This results in electronic transition involving valence electron from ground state to higher electronic state. They are called excited state. There are three types of electronic transition, which are transition involving sigma, pi, and n electron, transition involves charge transfer electron, and transition involves p and f electron in metal complex. Some transitions are forbidden for some complex. Whether the transitions are allowed or forbidden depends on selection rule. There are two selection rules, which are Leopard selection rule and spin selection rule. Firstly is Leopard selection rule, stated that only allowed transition in such molecule must involve a change in parity. This rule only affects octahedral and square planar complex. For the complex we choose is forbidden because its geometry is tetrahedral that didn't have center of symmetry like octahedral. The second one is spin selection rule, stated that transition that involve a change in spin multiplicity are forbidden. Any transition for delta S equal to 0 is allowed, while delta S not equal to 0 is forbidden. For this complex, the spin selection rule is forbidden. This is because when you see the electronic configuration for CD, which is the central metal ion, the d orbital of CD2 plus is fully filled, so there's no excited electron in d orbital. That results in no light absorbed in visible region. Therefore, color of this complex is white, like my friend mentioned before. Next, for the type of transition, there are four of it, which are sigma to sigma star, n to sigma star, pi to pi star, and n to pi star. Star is mean an excited orbital. This is the electronic molecular energy level for each transition. Because of its complex have presence of unsaturated functional groups that provide pi orbital, the result of electronic spectra of this complex show absorption 262 and 310. At 262 involve pi to pi star transition correspond to moving of electron from bonding orbital, which is pi, to anti-bonding orbital pi star. While at 310 involve n to pi star transition correspond to excitation of electron from non-bonding orbital, which is n, to anti-bonding orbital pi star.
Next, valence bond theory or VBT. VBT is proposed by two American scientists, which are Linus Pauling and John C. Slater. In VBT, we will explain about hybridization, geometry, and magnetic properties of the metal complexes. In VBT also, we have three basic principles. Firstly, hybridization of the valence orbital of the central metal. Second, bonding between the ligand and the central metal. Lastly, relation between the type of bond and the magnetic behavior. Magnetic behavior, which are magnetic properties, magnetic susceptibility, and magnetic moment. As we can see, this is our complex, so the cadmium will be the central metal. In ground state, cadmium will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, and 4d10. Or we can just use condensed electron configuration, which are krypton, 4d10, 5s2. In accepted state, cadmium will be cadmium ion 2+, and the electron configuration will be krypton, 4d10. In 4d orbital, it will be fulfilled by pair electrons. So for 4 type of ligand, which are 2NH2 and 2SH, will donate 4 electron each for 5s and 5p orbital. So the hybrid orbital will be sp3 and geometry will be tetrahedral. So our complex will be known as the low spin complex because there's no unpaired electron in our complex. And because all orbital will be occupied by the paired electron, so our complex will be known also as spin pair complex and diamagnetic compound. As I said before, our complex will be diamagnetic compound. So what is the difference between paramagnetic and diamagnetic? So paramagnetic will be contain one or more unpaired electron and will be attracted to a magnetic field. So diamagnetic will be contain all electron pair. So it will slightly repel by the magnetic field. Lastly, I will talk about magnetic moment. In our complex will be 0 bm because there's no unpaired electron in our complex. Next is references. This is the references that we use. Okay, that's all from us. Hope you getting know well about our complex. Till we meet again and thank you. Okay, untuk yang artikel pertama ni, dia pasal 26 pyridine dari carboxylic acid. Bagi aku okey, tapi macam dia punya ligand macam susah.
Okay. Dia punya
Aku tak suka yang ni sebab dia macam sikit.
ini
Yang satu.
Ni bio kan, more pada bio spektroskopi.
Yes. Biomolecular.
Dia nak kena baca
Alright.
bio lagi.
Ini nak
Tidak.
Abrar okey
tengok
ke?
ahli DNA.
Tak
Betul
juga.
ahli DNA.
Sama tadi pun reject juga.
Okey, artikel 4. Artikel barak.
We have synthesis.
Okay.
Yes. Activity of a transition metal complex.
Ini memang ada sintesis ni, tapi masalahnya gambar dia tak ada. Ada ke? Ini ke gambar dia?
Ada.
Ni ke gambar dia? Kedua, pasal for amino pill. Nama pun panjang nak mati.
Panjang tapi dia punya ni senang lah. Aku dah baca.
Senang. Pasal eksperimen dia senang lah.
Ni macam okey juga.
Kontennya banyak tak?
Pasal
Ada lah. Ada UV lah.
Kena
Ya, UV.
dia ada. Macam nombor 2 ni macam lengkap sikit.
Sekejap.
Okey.
Ni 2013, kira latest juga lah. Result dia complete lah. Just tinggal explanation.
So,
Okay.
kita guna lah yang kita pilih.
Ya, saya setuju.
Okay. Thanks Adinda.
Okay.
Kenapa lepas kompleks 1, kompleks 3? Mana kompleks?
Okay.
Alright, bagus.
So, contoh maknanya sekarang ni korang nak buat intro dengan conclusion problem. Sekarang characterisation bagi 2. Nombor 2 tu electronic program, nombor 3 tu program. So, kita bimbang. Itu korang nak.
Apa pendapat anda?
What is your opinion?
What is your opinion?
Itu tu yang sama Farah tadi lah. Yang satu orang yang tentu.
Characterization tu buat 2.
Like,
Mana boleh?
Aku masuk.
video aku.
Ya.
Tapi kau video diary kan?
Aku yang tolong konten itu. Aku nak buat
Saya nak cakap characterization.
Aku nak safety.
Aku ambil ni nak electronic transition.
Aku nak ambil intro dengan conclusion lah.
Intro conclusion
Nak pilih yang tu.
boleh.
Video tu.
Ha?
Nak bagi kat aku video.
Oh.
Saya
Nak siapkan slide dulu aku rasa.
Atau kalau boleh. Kalau boleh esok gitu.
Jumaat atau Sabtu pagi.
Semua okey. So kalau boleh dia nak lambat sangat.
Baik.